All right, hello everyone. So we are picking up on page 13 of our note packet. So this is kind of the very end, talking about two categorical variables. We've already done the table, which we'll see a bit more of in the handout. And now we are moving on to a side-by-side bar chart. And so as you can see from this graph, all we're doing here is we're putting count again on the y-axis, just like we did for the regular bar chart, and just like what we did for the histogram. And one of our categorical variables gets put on the x-axis. It's usually easier to read these charts if you put the variable with more levels on the x-axis. At least I find it that it's usually easier to read like that. And then the second categorical variable gets shades the bars different colors. And so in this case, a bar with no filling is yes, and a bar with black filling is no. And so how we want to read this bar chart is so does it seem like infield position whether or not the player hit more than 10 home runs are associated? From the bar chart, we're looking for kind of different patterns within each player position. And so because we do see that, like, okay, this has a lot more yeses than no, but this has very few yeses but a ton of nos, the fact that those patterns are very, very different tells us that there is an association. Or I'll say there does seem to be an association. And I'll just use first and second base as the examples because those are the most extreme. So because the pattern of first base players looks really different, I'll single out then the pattern of second base players and shortstops. All right, just because it has so many more yeses than nos, whereas it flips for the second baseman and for the shortstops. This is probably a bit easier to see if we draw what this would look like if home run and position were not associated. And so if that were the case, I'm going to kind of reproduce this graph. So first baseman, second baseman, third baseman, shortstop. If they're not associated, then the pattern of yeses and nos is just going to look the same. And so it might look something like that for the first baseman, maybe something like this for the second baseman. So the number of nos is about twice that of, a little more than twice that of the number of yeses. Same for the second baseman. Maybe third baseman look like this. Oh, that looks terrible. And shortstop looks like that. And so just kind of, there's not really anything that sticks out like it does in our actual data. We could also do the same thing with our table of counts. What would that look like if position and whether or not the player hit more than 10 home runs were not associated? And for now, we're just going to say that this is hard to do. But we're not just ditching it forever. We will come back to this when we do formal analysis. So we'll come back to that idea. This will end up being quite important for the formal analysis. All right, and so just like what we did with the bar chart, where we modified the y-axis to be proportion, We could do the same type of deal for our side-by-side bar chart, except make the y-axis have row percents instead of count. And so let's quickly kind of sketch out what that would look like. And so I'm gonna, let's see, I'm gonna come down here to the bottom of the handout where we have this extra space and just make a note that first we're gonna find all the row percents. So that would be kind of helpful before we graph them. And so let's see, yes, no, we've got first base, second base, third base, shortstop. Remember we had already found the row percent or the proportion for the first base players that have hit more than 10 home runs, and that was 65%. We could do the same type of calculation for all 8 cells. So I'll go down the column first. For second baseman, it's going to be 10 divided by 42 plus 10. And so that row percent is going to be 0.19. And then I'm just going to fill in what the rest of the row percents are. And like magic, they're there. So you could go ahead and pause the video real quick to fill those in. And all we're going to do now is just have these be our y-axis, so they're going to be proportion. We're still going to put first baseman, second baseman, third baseman, shortstop on the x-axis. We're going to use our same kind of coloring scheme for the yes, hit more than 10 home runs, and no. And I'm going to be extra careful now. Easy does it. Okay. Easy does it. All right, so that would be our first baseman. Second baseman, just go to 0.19 all the way up to 0.81. And 2.1 to 0.79. All right, so the important question is kind of like, well, why would we go through all the trouble of doing that? What's the advantage? And for groups that have like really different sample sizes, it's kind of easier to make the comparison. For example, it's a little bit harder from this graph to tell that these two groups are almost identical than it is with this graph. And so the advantage is really that it's easier to compare groups, which in this case are positions, with different sample sizes. In this example, it doesn't make a huge difference because all of the sample sizes are about the same, meaning that there's about the same number of first basemen as there are second, as there are third, as there are shortstops. So the graph doesn't look super, super different, but we'll see an example a little bit later where it actually does. Okay, so that wraps up our categorical variable data analysis, and we will continue next time going back to looking at a quantitative and categorical variable.